Okay, so let's think about this question. What is the probability that a tire wears out before 32,000 miles, right? So first, we are calculating this probability, which is a huge number, but we are going to standardize x to make it a standard normal distribution. We know the result, but at the same time, we have to work on the other side. So subtract the mean, divide by the standard deviation. Then you are going to get minus 0.6. Like the scale is now totally different because everything is standardized. You have to match the scale on like z to the other side and x to the other side. So anyhow, x is like several thousand miles, but z is around plus minus 2. And then this is a cumulative probability for standard normal distribution. Find it from Excel, right? So probability z is smaller than minus 0.6 is norm.s.dist minus 0.6 times true, comma true, right? It is this guy, 27.4%, right? So that is the probability we calculate using standard normal distribution. Now let's calculate probability greater than something. Previously, we learned cumulative probability, which is smaller than something. But now we will flip the direction of the inequality. How do we do that? The idea is similar. In the first step, we have to standardize x, right? That's our goal. We are going to standardize first. Right? And in doing so, you have to standardize its counterpart. Then 30,000 will become minus 1 after standardization. And then this is a probability about standard normal distribution random variable, right? How do you calculate probability greater than minus 1? You convert greater than something into 1 minus smaller than something. That is simple manipulation. And then find this guy from Excel, normal distribution table. So we already did it. We already have that here. We did it earlier. So the answer is 84 something, right? Now this is your turn. What is the probability that a tire lasts more than 37,000 miles? Okay, pause the video now and do it by your hand. Do it yourself and resume when you're done. I'm going to show you the answer, assuming that you have already finished the work. Right? Standardize in the first step. Standardize x and 37,000. It is like minus mean divided by standard deviation. You will get 0.4. Okay, so it is probability greater than something. So flip the inequality to have a cumulative probability. So 1 minus cumulative probability. That is what you find from Excel. Probability smaller than 0.4. So probability z smaller than 0.4 is 0.4 cumulative true. That is that. And then, but actually what we need is probability greater than 0.4. It is 100% minus this guy, right? So you may change it. So first, we calculate the cumulative probability first, and then turn that into the probability we want. Okay, so should be simple, right? Just it's a mechanical steps. Standardize, check if it's cumulative probability, and if you have cumulative probability, you may use Excel. That's the basic 3 steps when you calculate normal distribution probability. The third type is interval, right? Now let's find probability between 30,000 and 40,000. The first step is standardization, right? In here, when you standardize x in the middle, you have to standardize left and right at the same time. There are three because there are two inequalities. 3 terms have to have the same scale. You have to scale up and down at the same time for these 3 terms. So 30,000 is standardized by subtracting 35,000 divided by 5,000. You get -1. 40,000 is also standardized to 1, like this. So you get standard normal distribution between plus minus 1. And we learned how to find probability between 2 points. It is just the difference between 2 cumulative probabilities, right? Say, of course, in this case, 1 is the greater side, so probability up to 1 minus probability up to -1. How do you do that on Excel? We already calculated probability up to +1, probability up to -1. Take their difference, like this and this. So take difference probability between -1 and 1 is this minus this, which is 68%. Okay? The answer is 68%. Now try this. Do the same thing for different numbers. 32,000 and 37,000. Again, it is an important exercise. Try it by yourself. I'm going to resume. You have to stop the video. Okay, so as before, basic 3 steps. Standardize, convert everything into cumulative probability, use Excel, right? So first step, standardization. Standardize everything that is compared to X, right? So 32,000 and 37,000 must be standardized, and we know they are -0.6 and 0.4. And then it is a probability of an interval. So to transform that into cumulative probabilities, we use this method, Okay, and then find this cumulative probability from Excel, find this from Excel, right? Let me see. We already got these 2 probabilities, so their difference is 38%. That is the probability in between these 2 points, -0.6 and +0.4. So 38.11, right? That is how we use standardization and Excel to find probabilities. Okay? So summary. We have non-standard normal distribution, but does not matter. You transform those probabilities depending on the format, structure of the probability. You can express them as cumulative probabilities of normal distribution, standard normal distribution. So cumulative probability of standard normal distribution can be found using a calculator. Okay. Additional exercises. We need to think about percentiles. So now suppose that you want to say that 90% of tires last longer than a certain miles based on your distribution. What is the appropriate number in here? Right? So 90% of tires last longer than this miles. That means what you need is, like, you can write this as like this. You are going to write A here. If you write A here, A must satisfy probability greater than A is 90%. So you are going to standardize. So this is the clue. you are going to standardize x first, and then you get something like this, and you are going to find this probability equals 90%. So then you match A and B. Let me show you how it works. So standardization, we start from probability greater than A, but X is standardized, so A should be standardized, which is this. But in this case, A is unknown, so we cannot do anything further. This is all we can do, because A is unknown. A is what we are looking for. So I have no idea what this value is, but we know that it equals 90%. I don't know A, but I know its probability is 90%. Right? So then, we are going to start from Z and 90%. In the standard normal distribution, we know that 90% is given by minus 1.28. We learned it earlier because 90% is above 1.28, so it's like bottom 10%, 10 percentile. So then what I'm going to do is we are going to match these two equations. One is from standardization. This is from normal distribution, standard normal distribution. We match them in the third step. So this equals this. Like by simple rearrangement, you get A equals 35,000 minus 1.28 times standard deviation. That is this. Okay? So, and this is a very intuitive interpretation. So minus 1.28 is the distance from the mean. So mean is here. This is the mean. Starting from the mean, you have to go down by 1.28 standard deviation. So 1.28 times standard deviation is added to, subtracted from the mean. That is what you get. Okay? Now it is your turn. So try this. What is the appropriate number for the blank? 95% of tires cannot last up to certain miles. So here, this number, must be top 5% because 95% fail, but top 5% can go beyond this point. So it is top 5%. Top 5% is based on here, 1.64. That is the clue. So 1.64, remember that. So we can write it this way. 95% cannot last up to A. Like their life is less than A. That is 95%. Step 1, standardization. We have A minus mean divided by standard deviation. That's all we can do here. But as I said, we may use the knowledge from the standard normal distribution. 1.64 satisfies this equation. So 1.64 should correspond to this guy. Right? So they are same. In the end, A must be its mean plus 1.64 standard deviation. Right? 1.64 standard deviation above its mean. That can be written this way. That is 43,000. Right? So this chapter was more of an exercise. So intermediate summary up to here is when you are looking for percentile for non-standard normal distribution, still you may use standardization, right? And the idea is matching those two, or you can use the standardized value, C like value, B, and like add that much distance to the mean after multiplying standard deviation. So that's the idea of standardization. And we learned all these things. We learned how to calculate any probability or percentile in normal distribution, either standard or non-standard. So The reason why I did a lot of exercise here is because we are going to use these techniques in the later chapters. As I said, everything is based on the normal distribution, so you should be familiar with those techniques to handle the things that come up later. But that shouldn't but basically same algebra will be repeated. So as long as you understand what's going on, you are going to learn by many exercises in the end. So I don't worry too much about the algebra right now. So you'll see it later. Okay, thank you for watching. This is the end of chapter 6. Chapter 7 is related to chapter 6, but will be more interesting and something pretty different. See you later. Bye.